What if I told you the safety filters inside powerful AI models, the very systems meant to block harmful content, can now be switched off? Not hacked, not retrained, just flipped like a light switch. A US startup has discovered how to bypass these built-in guardrails without altering the models themselves. The implications? Massive. From national security fears to transformative use cases in healthcare, finance, and cybersecurity. This isn't just revolutionary, this is happening right now. Today, we're breaking down how they did it, why it matters, and the serious ethical questions it raises. AI censorship isn't a simple block list. It's deeply baked into the model's architecture. These models, whether from the US, Europe, or China, are trained from the ground up to avoid specific topics like violence, political extremism, and disinformation. This process starts at training time alignment, where models are fed curated data that steer them away from risky subjects. Then comes reinforcement learning from human feedback, RLHF, where human trainers reward safe answers and penalize unsafe ones. Over time, the model learns what to avoid. These filters aren't manual switches. They live inside the model's neural wiring, activated by clusters of neurons that function like muscle memory. When triggered, they prompt the AI to refuse or redirect certain responses. For years, these guardrails were thought to be nearly impossible to remove without retraining the entire model from scratch. But that assumption has just been shattered. Enter CTGT, a US-based startup that took a radically different approach. Instead of retraining or hacking the models, they identified the internal neural features that trigger censorship responses and learned how to dial them down. Picture it like finding the volume knob on the model's censorship reflex. Turn it up, the AI stays cautious. Turn it down, and suddenly the AI starts answering questions it was trained to avoid. Their process involved 3 key steps. 1. Feature identification. CTGT designed hundreds of prompts specifically meant to trigger refusals, questions about hacking, censorship, or sensitive political topics. By analyzing which neurons fired during these refusals, they mapped the censorship features. 2. Feature isolation. Next, they studied these features to understand how strongly each one influenced the model's behavior. Some blocked responses entirely. Others simply softened or redirected answers. 3. Dynamic feature modification. The breakthrough came here. Instead of altering the model's training, CTGT developed a method to adjust censorship behavior live, at the inference stage while the model generates its output. No retraining, no added data, just real-time control. To test their method, CTGT created 100 refusal-triggering prompts. Normally, the base model, DeepSeek, responded directly to only 32%. The other 68% were blocked. But after applying their censorship bypass, the response rate soared to 96%. Even more surprising, the model's factual accuracy remained stable. It wasn't hallucinating or generating nonsense. It simply answered questions it had always known but had been prevented from sharing. This approach didn't hack the system. It didn't retrain the model. It just reduced the influence of the censorship features on demand. This method isn't just about bypassing filters. It could reshape how AI is used across industries. In healthcare, doctors may need unfiltered AI input for complex cases, while patients require simpler, safer answers. In finance, analysts might need candid assessments of geopolitical risks that censorship would otherwise block. In cybersecurity, teams often need to explore malicious techniques to understand threats. But AI safety filters might prevent those discussions. Until now, the only way to handle these use cases was to fine-tune separate models, an expensive and time-consuming process. CTGT's method changes that. It offers real-time, reversible control over a single model's behavior, no retraining required. But here's the catch. The same feature that makes this so useful makes it dangerous. If hospitals or security teams can toggle censorship off, what's stopping a bad actor from doing the same? Imagine hostile governments or cyber criminals using this technique to bypass filters and generate disinformation, phishing scams, or malware code. The U.S. Congressional Select Committee on the Chinese Communist Party has already flagged DeepSeek, one of the models CTGT tested, as a national security risk. Their concern? In its unfiltered state, a model like this could be weaponized for propaganda, cyber attacks, or espionage. And because CTGT's method operates at the inference level, in other words, real-time data, not the training level, No hacking or developer cooperation is required. Anyone with access to open-weight models like Llama 2 or DeepSeek could potentially apply this method. But here's where things get even more complicated. Most AI safety regulations, like the US Executive Order on AI or the EU AI Act, focus on training data and development practices. The assumption was, control the training, control the behavior. But CTGT's method bypasses all of that. It works after deployment, at runtime. It's like building the world's safest car, only to discover someone can disable the brakes after it leaves the factory. Current laws aren't designed to address this kind of inference-level modification. There's no clear plan for what happens when someone flips the safety switch after deployment. Some experts argue that this method could help companies comply with different global content laws by adjusting censorship levels across regions, without retraining models for each market. But critics warn that giving companies this much control is like handing out censorship remotes and hoping they won't be abused. Governments are scrambling to respond, but their current policies weren't built for this kind of control. The question now is, who should decide when filters get turned off? And how do we prevent abuse? This breakthrough caught major AI developers off balance. Companies like OpenAI, Meta, and Anthropic had counted on safety features being hardwired into their models. Now they're faced with an uncomfortable reality. Those features can be bypassed without their consent. If they lock down their models too tightly, they risk slowing innovation. But if they stay open, they risk losing control over how their tools are used. Some insiders suggest turning CTGT's method into a compliance tool, offering proof that censorship can be adjusted responsibly. But others fear it's just a backdoor waiting to be exploited. CTGT's discovery didn't hack AI. It revealed just how fragile our assumptions about AI safety really are. It's not just about alignment at training time anymore. It's about control at runtime. Behavioral programmability is here, offering power, flexibility, and risk in equal measure. So the real debate now isn't just about technology. It's about trust. Who should hold the remote? Let me know what you think in the comments.